Good morning. Today we are going to cover section 7.8, partial fractions. So write down your essential question. Take the time to write down your essential question. How do you write a rational expression as the sum of two or more simpler rational expressions? Go ahead and take the time to glue your cutout or you can copy it down as well. And we'll start once you are ready. Go ahead and pause it. Excellent. So today we're going to cover something called partial fraction decomposition. So if we have a rational expression, where we have a polynomial or function divided by a function, a polynomial divided by polynomial, we can simplify it. So a rational expression can be written as the sum of two or more simpler fractions. So basically what we're doing, if we have a rational expression, we can break it down as a sum of two expressions. Back from Algebra 1 and Algebra 2, we kind of did the opposite, where we had the sum of two expressions, we added them together. So now, not till now, are we going to have the tools to be able to go the other way. And there are three simple rules. Divide. So if your expression is improper, then we can actually do the long division to be able to divide it. If you have linear factors on your denominator, so once we factor your denominator, if we have linear factors such as x minus 3 and x plus 2, then we're going to follow the following rule. So for each factor of the following form, we're going to have several ones. And we'll start that on example number 1. But if we have quadratics, so if it's improper, we need to divide. If it has quadratic factors, then we're going to use this form. If it has linear factors, we're going to use this form. If the denominator cannot be factored, then there's no decomposition. But let's go through example number 1. Go and copy it down, and we'll start once you're ready. Go and pause it. So first thing that we need to check is it proper or improper? In this case, remember, improper fractions is whenever we have 7 divided by 2. That's an improper fraction. 2 goes into 7 3 times. We usually write down 1/2, but we know that there should be a plus in between that we're not going to write down. So this is going to be the same case. If your degree of the polynomial is bigger on the denominator, then this is a proper fraction. So therefore, we don't need to do a long division or symbolic division. Then we need to be able to find the linear factors for your denominator. And we're going to decide whether they're linear or quadratic. So therefore, I'm going to go and rewrite it. My numerator will stay the same, x plus 7. My denominator, I'm going to go and rewrite it as one factor using double parentheses. So therefore, if I factor this out, factors of x squared gives me x and x. Factors of 6 will be 3 and 2. 1 negative, 1 positive. I need to end up with a negative x, so that should be a negative 3 and a positive 2. So therefore, those two expressions are equal. So let me go and rewrite it over here on the left-hand side. So you only allow space throughout this problem. So just make sure you give yourself enough space. So therefore, the denominator can be factored, so therefore we can go through this process. And if you notice, the denominator only has linear factors. So therefore, we're going to just use one letter on the numerator. And we're going to use for each one. In this case, there's only linear factors, and they're only to the exponent of 1. There's only 1x minus 3, and there's only 1x plus 2. So we don't have to worry about this case here. We're just going to use the first one. So what we're going to do we're going to write down the first one will be x minus 3 plus the second one will be x plus 2. This is a linear factor, so we're going to place in A. This is a linear factor, so we're going to place only one letter, which will be a B. If you have another one, it'll be a C. And now we have an equation. We know that those two expressions should be equal to each other. So now we can go to solve for A and for B. And the way that we're going to do this is that we are going to cancel your denominator, just like you guys did back in Algebra 2 when you solve rational expressions or equations. I'm going to multiply by the denominator to cancel it. So I'm going to multiply by x minus 3, x plus 2, x minus 3, x plus 2, x minus 3, x plus 2. So in this case, they all cancel. So my x minus 3 cancels, my x plus 2 cancels. So I only have x plus 7 equals. On the next, I'm going to cancel my x minus 3. So therefore I have my a and my x plus 2. On the next one, I'm going to cancel my x plus 2. And I have a plus b, x minus 3. And there's several ways to solve this problem. I'm going to keep it the same throughout. So I'm just going to simplify this expression. And this is something that sometimes appears on your SAT. So this should be helpful. I'm just going to simplify this. A times x will be ax. A times 2 will give me 2a. B times x will give me bx. B times negative 3 will give me negative 3b. And I have my x plus 7 on the left. Now I can move things left and right, but that's not going to help me in this process. So what I need to do, I'm going to pair up my x's, and anything that's not having x, I'm going to group them together because I know that both x's should be equal to x, and those two numbers should be equal to 7. So let's go to the next step. I'm going to pair up my x's, so we have ax plus bx. We have 2a minus 3b. We have x plus 7. I'm going to factor out my x from those two expressions, from those two terms. So therefore, if I factor out my x, I have a plus b. Nothing to factor here, so I have plus 2a minus 3b. We know that the coefficient for x is 1. So therefore, if those two expressions are the same, are equal to each other, then I know that my 1 should be equal to the x. Do you guys agree? And my 7 should be equal to this expression here. So therefore, we're going to set up two equations. I know that, and I should say my a, this expression is equal to this expression. So therefore, my 1 should be equal to my a plus b. So therefore, a plus b has to be equal to 1 in order for those two expressions to be the same. And 2a minus 3b has to be equal to 7 in order for those two expressions to be the same. And now we have a system of equations. And I need to decide. I have two equations with two unknowns, so therefore I can solve it. If you have three unknowns, you need three equations. If you have four unknowns, you need four equations and so on. So therefore, I have to make a decision. Do you guys want to solve it by combination, substitution? We can graph it. We can use matrices, Cramer's rules, the inverse of matrix, or by augmenting matrix. Correct. By combination would be easier. So this lesson is part of your linear systems of equations, but since there's so much in chapter 7, I actually covered right before chapter 12. But in this case, we have two equations. I need to be able to solve it. I need to make a decision. Do I want to cancel the a's or the b's? I'm going to cancel let's cancel the a's. So therefore, I'm going to multiply this expression by -2. And let me rewrite it here. So it gives me -2a. So the a's cancel. -2b and -2. So therefore, my a's are gone. And I have -5b is equal to 5. So therefore, b equals -1. And now I can solve it. So I'm going to find a. So find a and see what you get. Composite. So in this case, I'm going to plug in a plus -1 equals 1. So therefore, a equals to 2. Therefore, we found the value of a and b. I'm going to use this expression since this is what we started with, just to be able to show my final solution. So x plus 7 over x squared minus x minus 6 equals, my first is x minus 3. My second one is x plus 2. My a is 2. My b is -1. So therefore, those two expressions should be equal to each other. So what's one way to find out? Correct, to multiply it out. So let's go and check. That means that if I multiply those two, this expression, 2 over x minus 3 plus -1 over x plus 2, I can add both expressions by making them the same denominator. So I'm going to multiply this side by x plus 2. Multiply this side by x minus 3. So that way we have the same denominator. So it gives me 2x plus 4 over. Since they have the same denominator, let me just multiply it out. So it gives me x squared minus x minus 6. That gives me -x plus 3. Same thing, so I end up with x squared minus x minus 6. They have the same denominator, so now I can combine them into 1. So it gives me x squared minus x minus 6. Combine like terms, so it gives me x plus 7. Check. So fraction decomposition is just basically what we were doing in algebra 2 where you were adding. Now we can have the reverse process. So we can break down one fraction into 2. But remember that in order for this to be possible, your denominator should be able to be factored. So let's move over to example number 2. Go and copy it down and then we can start once you are ready. Excellent. So first we need to check, is this a proper or improper fraction? If you notice your degree of the polynomial, in this case the degree is bigger on the denominator, so therefore this is a proper. We cannot divide it up. So we don't have to use long division, so we don't have to divide. Then I need to decide whether my factors are going to be linear or quadratic. So we're going to factor this out. I'm going to factor on the left-hand side. I have x to the third minus 2x squared plus x. And I can factor the common factor, take out the common factor, which is x, and what's left, x squared minus 2x plus 1. I can still factor this out. Double parenthesis is a trinomial, so it'll be x and x, factors of 1, 1 and 1, and they both should be negative. They both are the same, so we can rewrite it as x minus 1 squared. And you want to do that when you have a perfect square trinomial, rewrite it as x minus 1 squared, because that will be means that we have to use for every factor, in this case is square, so we're going to have 2 instead of just 1. So you can't just do it this way. We have x minus 1 and x minus 1, and let's talk about that in a minute. So we have 3x squared minus x plus 5 over x minus 1 squared. Let me go and copy it over here. So we have 3x squared minus x plus 5 over x minus 1 squared. I'm going to start with my first factor, x. It's a linear factor, so it gets only one letter. Remember that we've only done linear factors so far. So if it's a linear factor, we are just going to use one letter. If it's a quadratic factor, we are going to use 2 letters. So right now, this is a linear factor, that's a linear factor, that's a linear factor. So we're only working with one letter on the numerator. So therefore, this is going to be an A plus. According to the rule, if you have more than one, we're going to place it twice. The first time is going to be x minus 1. The second time will be x minus 1 squared. If this was to the third power, then we'll need another one plus x minus 1 to the third power. So therefore, this one, it's a linear factor, so it gets a B, and this one gets a C. Now, some of you guys might get it incorrect. If you rewrite it, and I've seen this before, where they rewrite it as 3x squared minus x plus 5 over x minus 1, and x minus 1. End up with a x plus b x minus 1 plus c x minus 1. This will not be correct. It's not going to be the full simplified version of it. So just be careful. So you want to make sure that you get used to just rewriting it as x minus 1 squared. And now we have an equation that we can solve for a, b, and c. Now we want to cancel my denominator by multiplying by x minus 1 squared. So x minus 1 squared, x minus 1 squared, x minus 1 squared, x minus 1 squared. So therefore my x and x minus 1 squared, that cancels. So the only thing that I have left is my 3x squared minus x plus 5 equals. On the next one, only my x cancel. So therefore I have a multiplied by x minus 1 squared. On the next one, only one of my x minus 1 cancels. So therefore I have plus b x minus 1. And on the last one, my x minus 1 cancels. So therefore I have plus cx. And now I can solve it. Now there's different ways of solving this. There's 2 ways that the book covers it in 2 different ways. We're just going to cover it in one way, where we're just going to simplify the right hand side and then pair up with the corresponding coefficient. So I know that x minus 1 squared is, we just did it backwards over here, so that'll be x minus 1 x squared minus 2x plus 1 plus, let me just multiply this out, gives me bx times x is bx squared, bx times negative 1 will be negative bx plus cx. Let me take an extra step to multiply this out. Copy this down. So therefore, this expression stays exactly the same. And now I need to group my x's to get x squares together, because my x squares together combined should be 3x. I'm going to group my x's together because combined will be negative x. And anything that does not have an x will be equal to 5. So let's say I have my x squares first. Then I'm going to combine my x's, or just pair them up right now. And last we have my a. Next, I'm going to, I forgot to write down my x squared. Next, I'm going to combine my x squares together, or, well, actually, can't combine them, so I'm going to factor my x squared from both. And what's left behind? We have a plus b. I'm going to factor out my x from the next three. So I'm going to factor a positive x. And what's left behind? We have a negative 2a minus b plus c. And last, we have an a, nothing to do with it. We have 3x squared minus x plus 5 equals. And now I'm going to pair them up. We have first my x squared. So therefore, my 3 should be equal to a plus b. Then my negative 1x, my negative 1, and I'll place a 1 in there, should be equals to this expression, negative 2a minus b plus c. And last but not least, my 5 should be equals to a. So if this is expressions equal to each other, then I can pair them up. And this is something that you see this type of expression in your ACTs. Sometimes it's worded slightly different, but the process is the same. So now I can just go and make my equation. So therefore we have a plus b equals 3. We have negative 2a minus b plus c equals negative 1. And a equals 5. And notice this is the way I write them next to each other, because many times you can just substitute back in. Or sometimes you can place them on top of each other, and you can solve it by combination, by substitution, graphing. We can use matrices, augmented matrix, the inverse matrix, Cramer's rule. But in this case, we know that the value of a is 5. So I'm just going to plug in a 5 in here. So plus b equals to 3. So therefore b equals negative 2. And I'm going to plug both of them in here. So I know the value of a is 5. The value of b is negative 2 plus c equals negative 1. Negative 10 plus 4 plus c equals negative 1. So it gives me negative 7 plus c equals negative 1. C equals to 6. And now I can just set up my equation. I know the value of a, b, and c. So we have 3x squared minus x plus 5 over. I'm going to use my original equation or expression. We have x plus x minus 1 plus x minus 1 squared. We have a is 5, b is negative 2, c is 6. Therefore, that is a fraction decomposition. Now, how can we check it? We can add all those three expressions, and that should be equal to this. Should we try it? Sure, let's try it out. Adding them at this point is a very quick process. So therefore, I need to have the same denominator in order to add three fractions. This one will need x minus 1 squared. This will be needing an x and an x minus 1. Remember that whenever you multiply, you need to multiply the numerator and the denominator, and this one just needs an x. So I know that x minus 1 squared is x squared minus 2x minus plus 1, so I'm just going to multiply it out. It gives me 5x squared minus 10x plus 5. And I'm going to keep my denominator as x minus 1 squared, plus negative 2x times x gives me negative 2x squared. Negative 2x times negative 1 is positive 2x over x and x minus 1 squared plus 6x x minus 1 squared. Now I can multiply this out, but I already know that I already multiplied backwards. So therefore this should be x to the third minus 2x squared plus x, according to our previous work. I'm going to combine like terms, and if I did it correctly, I should end up with this expression here. Let's combine my x squares. That gives me 3x squared. Combine my x's. We have negative 8 plus 2 gives me negative 2. So where did I go wrong? So therefore, I messed up. Diaz messed up. Can you guys find my mistake? So it doesn't work because that gives me 4x. Yeah, it's over here. Diaz messed up over here. So let's make a few changes. So it's a positive 2. That gives me negative 8. That gives me a 7. You probably saw that when I did the work. Therefore, this should be a 7. Correct? So therefore, that is negative 8 is negative 1x. And that gives me a positive 5. So that's why I thought it was important to check it. Make sure that you get the correct answer. Excellent. So that is example number 2. Let's continue to example number 3. Example number 3. Go ahead and write it down, and then we can go through the process. Excellent. So in this case, first, we need to make sure that the rules is to decide if this is a proper or improper fraction. So in this case, my denominator has the largest degree, so therefore this is a proper fraction. So we can start the process. Then I need to decide whether they're going to be linear or quadratic factors. So I'm going to factor my denominator, and I'm going to factor on the left-hand side. So we have x to the third plus 4x. And I can factor an x out, and what's left behind? We have x times x squared, x times positive 4. Can I factor this out? Well, this can be factored out, right? Do you guys remember how to factor this out? Will be x and x. What are the factors of 4? 2 and 2. 1 negative, 1 positive. That'll be 2i. If we multiply it out, we end up with x squared plus 2ix minus 2ix minus 4i squared. That cancels, so I end up with x squared. That gives me negative 1, so it gives me a positive 4. But in this case, we actually want just linear factors that are real. So that cannot be factored out unless you use imaginary or complex numbers. So we're going to leave it as x squared plus 4. and we have 3x squared plus 4x plus 4. And now we can use fraction decomposition to break it down. We have 3x squared plus 4x plus 4 over x squared plus 4. And now, according to our rules, they're proper. We need to decide if they're linear or quadratic factors. Notice that in this case, my x is a linear factor, and my x plus 4 is a quadratic factor. So therefore, when it's a linear factor, you just have a. Whenever it's a quadratic factor, you have bx plus c. Or you just have two letters, either a, b, b, c, or so on. In this case, we're going to use the first letter, a, for the first one. This is a quadratic factor, so this will be bx plus c. So be careful. Notice the difference between having the square outside. This is a linear factor because there are 2x minus 1, and we just rewrite it twice. This is x squared plus 4. This is a quadratic factor that we were not able to factor, and therefore gets two variables. And now we can solve for a, b, and c. We want to get rid of the denominators once again, so we can multiply by x squared plus 4, x squared plus 4, x squared plus 4. On my first one, everything cancels out. So therefore, I have 3x squared plus 4x plus 4. On the second one, my x cancels out. So therefore, I have a multiplied by x squared plus 4. On my last one, my x plus x squared plus 4 cancels out. So therefore, I have a plus bx plus c multiplied by x. I'm going to simplify the right hand side. So this expression stays the same. Ax squared plus 4a plus, multiply this out, bx squared plus cx. I'm going to group them together. And I'm going to group my x squares together, then my x, and then my c, my number. So we have ax squared plus bx squared, then plus cx, and plus 4a. And now, I want to be able to factor my x squared from here. And some of you guys will start doing it in fewer steps. Just be careful. I'm actually just writing every single step right now. And according to this, my 3 should be equal, if those two expressions are the same, my 3 should be equal to a plus b. My 4 should be equal to c. And last but not least, my other 4 should be equal to 4a. So let's go and write down underneath. We know that a plus b should be equal to 3. We know that c should be equal to 4. And we know that 4a should be equal to 4 if this expression is true. So we have the value of c. We know that the value of a should be equal to 1. Once you solve it, we're going to plug those in. And the only thing we're plugging is the 1 here. We have plus b equals to 3. Therefore, b equals 2. And now we can write down our expression. We have 3x squared plus 4x plus 4. I'm going to use my original expression over x to the third plus 4x we have the first one under x, the second one will be x squared plus 4. My a value is 1, my b is 2, so it'll be 2x, and my c is plus 4. So therefore, we broke down our rational expression into the sum of 2 or more, in this case just 2. And we can check it. So let me just check it, just make sure I... Checking is a very quick process at this point. So therefore, I need to have the same denominator. I'm going to multiply this side by x squared plus 4. I'll multiply this side by x. So therefore, now we have the same denominator. That gives me x squared plus 4 over x squared plus 4. Plus, multiply this out, it gives me 2x squared plus 4x over x squared plus 4. I can multiply my denominator to be x to the third plus 4x. They're exactly the same. Combine my like terms. We have 3x squares plus 4x and plus 4. So therefore, it matches. Example number 4. We can copy it down, and then we can start once you're ready. Pause if you need more time. So once again, our rules is that we need to decide whether the fraction is improper or not. In this case, your denominator has the biggest degree of the polynomial. This degree is 4, this was 3, so therefore this is proper. On the last example, we'll cover one that's not proper. So therefore, we can factor the denominator. If we cannot factor the denominator, then we're done. We cannot decompose this fraction. So how can I factor this out? So in this case, I can just use my double parentheses. It's a trinomial, nothing to factor out. So there'll be just x squared and x squared. Factors of 2, 2 and 2, and they both should be positive. That's x to the fourth, 2x squared and 2x squared is 4x squared, and then positive 4. They both are exactly the same, so it's essential that you rewrite them as x plus 2 squared. So therefore we have x to the third plus 13x over x squared plus 2 squared. So we have an x plus 2 squared on my denominator, which is a quadratic factor. So therefore I'm going to have to use this expression. And because it's square, that means I need to be able to do a second one. If it was to the third power, then I need to do the third one as well. So in this case, we are going to end up with x squared plus 2 plus x squared plus 2 squared. If it was to the third power, then I end up with x squared plus 2 to the third power. And now, on my numerator, according to this, will be a linear x plus. So this will be, first, we don't have a, so it'll be ax plus b. So the next will be cx plus d. And now I can go through a process of solving. Go ahead and pause it, solve it, see what you get, and then we can compare our answers. You guys ready? So in this case, we're just going to cancel my denominator, so I'm going to multiply by x squared plus 2 squared, x squared plus 2 squared, and x squared plus 2 squared. On the first one, my entire denominator cancels out, so therefore I have 8x to the third plus 13x equals. On the next one of my x squares cancels out, so therefore I have ax plus b multiplied by x squared plus 2. On my third one, both of them cancel out, so therefore I have plus cx plus d. And now I can group them together. I can multiply this out, and I end up with, so if we have ax to the third plus 13x equals ax to the third power plus 2ax plus bx squared plus 2b. Plus cx plus d. And now I can go through a process and group my x to the thirds together. It's only 1. My x squared is only 1. I'll group my x's together. And it does not have an x. I'm going to place it together. So therefore I have ax to the third plus 2ax plus cx. Oh, I forgot my bx squared, right? Let me make space for it. Plus bx plus 2ax plus cx plus 2b plus d. And now I can factor out, let's say my x, I can factor an x from those two expressions. This one I'm just going to keep together. So therefore I have ax to the third plus bx squared. I'm going to factor an x, so I have plus x, and I have 2a plus c plus 2b plus d. Now in this case, I don't have an x square, so therefore I'm going to make some space, and I'll place a 0x squared plus 13x plus 0 as well. So that way I can pair up each one. And now I have my 8 will be equal to a, 0 will be equal to b. We have 13 will be equal to 2a plus c. And last will be 0 equal to d, to this expression here. So let's write them down. We have a equals 8, b equals 0, 2a plus c equals 13, and 2b plus d equal to 0. And now we can solve it. We know that a equals to 8, so I can plug my 8 in here. B equals to 0, so we have 2 times 8 plus c. So we have 16 plus c, therefore c equals -3. I want to place my b as a 0, so we have 2 times 0 plus d, therefore d equal to 0. So we found all the values. Now there's going to be times that you do need to be able to do it by combination, just like the 3 by 3s, but in this case we don't. So let me rewrite my expression. We have 8x to the third plus 13x over. Let me write down my original expression, which is x to the fourth plus 4x squared plus 4 equals, I have x squared plus 2. My 8 is 8, my b is 0, so therefore I just need 8x plus my c is negative 3, but my d is 0. So therefore I just need negative 3x. So according to work above, these two expressions will be the same. Now, how can I check it? By just adding both fractions. So we have 8x over x squared plus 2 plus negative 3x x squared plus 2 squared. I need to have the same denominator, so therefore this is the only one that needs an x squared plus 2. My denominators will be the same, which is x squared plus 2 squared. Multiply this out, gives me 8x to the third plus 16x. This one stays the same. I'm not combining like terms, so the only things I can combine are those two expressions. And plus 13x. Let me just multiply this out, and we already know that's x to the 4 plus 4x squared plus 4, and we are done. We have the correct answer. And the last example for today. Well, pause if you need more time to write it down, and we'll start once you're ready. So in this case, our first rule, divide if the fraction is improper. In this case, your numerator has the largest degree, so that's an improper fraction. So I'm going to use the long division, and let me make a little more space. So actually, this should be fine. I'm going to use my long division to divide this, and we have x to the fourth plus 2x to the third. We have x to the third plus 2x squared plus x. Now, I need to be able to use the long division, so we'll start. What do I need to multiply x to the third to end up with x to the fourth will be x. I'll place it right over here. X times x to the third is x to the fourth plus 2x to the third plus x squared. Then we change the signs. Opposite. So therefore, this cancels out. This cancels out as well. And now we have 5x squared. We bring down the next two terms. And what do I need to multiply x to the third to end up with 5x squared? You can't, because this is a lower exponent. So now I'm going to rewrite it as x plus 5x squared plus 20x plus 6 by my divisor, which is x to the third plus 2x squared plus x. I'm going to ignore this part. So I'm just going to use my fraction decomposition for this section here. And I'm going to factor this part out. Let me factor out on the left. We have x to the third plus 2x squared plus x. So I can factor, common factor, take out the x, and what's left behind? We have x squared plus 2x plus 1. A perfect square trinomial, so therefore there'll be x plus 1 and x plus 1, or x plus 1 squared. Now, remember, I'm only going to use my fraction decomposition for this part. But I still have my x that I'm going to use as my final answer. So therefore, we have x plus 1 squared. And we have 5x squared plus 20x plus 6. And now we go through the same process just like we did on example number 2, 3, and 4. So first, x, is that a linear factor or a quadratic factor? That's a linear factor. So therefore, that gets only one letter. X plus 1 squared, that's being squared, so that means that we're going to have two of them. This is also a linear factor. The first time, x plus 1 squared. If it was to the third, then we'll need to do a third one here. And this case is only to the second power. And now this will be a b, and this one only gets one letter, c, because that's a linear factor. If this is for a quadratic, then it gets two letters. And now we can cancel my denominators by multiplying by x plus 1 squared, x plus 1 squared, x plus 1 squared, x plus 1 squared. My entire denominator cancels out. X squared plus 20x plus 6 equals. My x cancels out. So therefore I have a x plus 1 squared. My x plus 1 cancels out, only one of them. So therefore I have plus b, x plus 1. My x plus 1 cancels. So therefore I have plus c multiplied by x. So now go and simplify it and then see what's the value of a, what's the value of b, and what's the value of c. And play once you're ready. So in this case, this is the same. Let me show a nice space. 5x squared plus 20x plus 6. I know that this is x squared plus 2x plus 1. So multiply by a gives me ax squared plus 2ax plus a. Multiply this out, bx squared plus bx plus cx. And now I'm going to combine like terms, and I'm going to factor my x squared right away, because I know I can factor an x squared, so I can save myself one step. And I'm sure some of you guys are already doing that. I'm going to combine my x's, and I'm going to factor out my x. So plus x. What's left behind? We have 2a plus b plus c. And then we have a lonely a. And now I can pair them up. My a should be equal to a plus b, according to this expression, if that's correct. My 20 should be equal to 2a plus b plus c. And my 6 should be equal to a. We have a plus b equals 5. 2a plus b plus c equals 20. A equals to 6. So therefore, I can just go through the process and solve for, well, A is already done. I can solve for B, and I can solve for C. So therefore, I'm going to bring my A here, which is 6, plus B equals 5, so therefore B equals negative 1. I'm going to plug both of them in. So you have 2 times A, which is 6 plus negative 1 plus c equals to 20. So it gives me 12 plus negative 1 plus c equal to 20. 11 plus c equal to 20. Therefore, c equals 9. And now I can just set up my expression. So finally, let's go and copy the original column, which we have x to the fourth plus 2x to the third plus 6x squared plus 20x plus 6 over x to the third plus 2x squared plus x. That will be equals. Now remember that this expression here is this one here, but we still need my x. So let me not forget my x there. That's part, this expression is equal to this here. So therefore, since I only decompose this part, I still have my x as part of it. So now plus x plus 1 plus x plus 1 squared. So therefore, my a value is 6, my b value is negative 1, and my c value is 9. Now we can take the time to check it, but at this point you guys can check it on your computer once you go through the process. But we can actually multiply or add those 4 expressions and take it from there. Okay, this will conclude the lesson for today. Email me if you have any questions, and have a great day.